Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a paragraph type question on angular momentum, torque, and angular velocity of a projectile. The question is as follows. Read the paragraph carefully. A particle of mass 1 kg is projected from O with speed 20 root 2 meters per second at angle 45 degrees with horizontal as shown in the figure, where P is the highest point in its path. Take acceleration due to gravity is equal to 10 meters per second square. Now answer the following. Question 1. Magnitude of angular momentum of the particle at P about O is, the options are 300 kg meter square per second, 360 kg meter square per second, 400 kg meter square per second, and 480 kg meter square per second. Question 2. Magnitude of torque acting on the particle at P about O is, the options are 400 Newton meter, 480 Newton meter, 500 Newton meter, and 540 Newton meter. Question 3. The angular speed of the particle at P about O is, the options are 0.1 radian per second, 0.2 radians per second, 0.4 radian per second, and 0.8 radian per second. We will solve the problems using vector method. But before that, let us recall the related concepts. Consider the path of a particle of mass m projected from O with speed u making angle theta with horizontal as shown in the figure. Let us recall the expressions for its horizontal range and maximum height, which are given by r is equal to u square sine 2 theta divided by g and h is equal to u square sine square theta divided by 2g. Now, position vector of the highest point P is given by r is equal to OA plus AP. Now, OA is equal to r by 2 and it is along the positive x direction, and AP is equal to h and it is along the positive y direction. Therefore, we write r is equal to r by 2 into I cap plus h into j cap. Now, the particle at P moves parallel to x-axis and its speed is u cos theta. Therefore, we write v is equal to u cos theta into I cap. Now, the angular momentum of the particle at P about the point of projection O is given by L is equal to R cross P, where P is the linear momentum of the particle. Now, the only force acting on the particle is its own weight mg, which acts in the vertically downward direction, which is the negative y direction. Therefore, we write F is equal to minus mg into j cap. and torque acting on the particle at P is given by tau is equal to R cross F. Now we are in a position to solve the problems in the question using these concepts. First, let us evaluate the physical quantities necessary to solve the problems using the given data as follows. It is given that mass of the particle is equal to 1 kg, speed of projection is equal to 20 root 2 meters per second, angle of projection is equal to 45 degrees, and acceleration due to gravity is equal to 10 meters per second square. Now, velocity of the particle at P is v is equal to u cos theta. Putting the values of u and theta, we get v is equal to 20 meters per second. It is in the positive x direction. Therefore, we write the velocity vector as v is equal to 20 meters per second into I cap. And linear momentum of the particle is P is equal to mv. Since m is equal to 1 kg, we have the linear momentum vector of the particle at the highest point is equal to 20 kg meter per second into I cap. And force acting on the particle at P is F is equal to minus mg into j cap, which is equal to minus 10 newtons into j cap. Now, horizontal range R is equal to u square sine 2 theta divided by g. Putting the values of u, theta and g and simplifying, we get R is equal to 80 meters. Similarly, maximum height is equal to u square sine square theta divided by 2g. Putting the values and simplifying, we get h is equal to 20 meters. Now, the position vector of the particle at P is r is equal to r by 2 into I cap plus h into j cap. Putting the values of r and h, we get r is equal to 40 meters into I cap plus 20 meters into j cap, which gives r square is equal to 40 square plus 20 square is equal to 2000 meters square. Now, moment of inertia of the particle of mass m about O, which is at a distance OP is equal to r from O, is given by I is equal to mr square. Putting the values of m and r square, we get I is equal to 2000 kg meter square. Now, let us solve the problems in the question. First, let us solve the problem in question 1. We start with the vector equation L is equal to R cross P. Putting the values of R and P, we get L is equal to 40 I cap plus 20 j cap cross 20 I cap. Distributing the cross product, we get L is equal to 800 into I cross I plus 400 into j cross I. Now, I cross I is a null vector and j cross I is equal to minus k, which gives L is equal to minus 400 k cap. Therefore, the magnitude of angular momentum is equal to 400 kg meter square per second. Therefore, the correct option is C. Now, we will solve the problem in question 2. For this, we start with the vector equation tau is equal to r cross f. Putting the values of r and f, we get tau is equal to 40 I cap plus 20 j cap cross minus 10 j cap. Distributing the cross product, we get tau is equal to minus 400 into I cross j minus 200 into j cross j. Now I cross j is equal to k and j cross j is a null vector, which gives tau is equal to minus 400 k cap. Therefore, the magnitude of torque is equal to 400 Newton meter. Therefore, the correct option is A. We will solve the problem in question 3 using two methods. The first method, the situation is shown in the figure. The particle at P is moving with velocity v parallel to x-axis. The position vector of P is r is equal to OP. Let OP make angle alpha with x-axis as shown. Then angular velocity of the particle at P about O is defined as omega is equal to velocity of the particle perpendicular to OP divided by distance OP. Now velocity of the particle perpendicular to OP is equal to v sin alpha. Therefore, we have omega is equal to v sin alpha divided by r. Again, from right angle triangle OAP, we have sin alpha is equal to h by r, which gives omega is equal to vh by r square. Putting the values of v, h and r square and simplifying, we get omega is equal to 0.2 radians per second. Therefore, the correct option is B. Now, for the second method, moment of inertia of the particle of mass m at a distance r from O is given by I is equal to mr square. Putting the values and simplifying, we get I is equal to 2000 kg meter square. We have already evaluated L is equal to 400 kg meter square per second. Now, angular momentum, moment of inertia and angular velocity are related as L is equal to I omega. Putting the values, we get 400 is equal to 2000 into omega, which gives omega is equal to 400 divided by 2000, which is equal to 0.2 radians per second. Therefore, the correct option is B. This completes the answer to the question.